Hello and welcome to another Flightstream tutorial. Today we will be going over a simple wing body mesh setup. The first thing we're going to do is import our wing body mesh. Then we're going to check the surface normals of our mesh. Here we can see that the fuselage is pointing inwards, so we'll flip that to the proper orientation, and then we'll unite the mesh together. From here, we're going to prepare our half model, starting by cutting the mesh in half down the center line of the XZ plane. Then we will select the mesh faces that are below the XZ plane in the Y direction and delete them. Now we're going to confirm that our half model is created correctly. With the unite and the deleting of the faces confirmed, next we're going to move on to defining our boundary conditions. First, we're going to auto-detect our trailing edges and wake termination nodes, and we'll move on to the solver to set up those boundary conditions. We're going to enable viscous coupling, as well as define our airfoil separation and vortex separation. To define our vortex separation, we need to know the maximum diameter of our fuselage. After measuring, we'll fill in the max diameter as the 2.6. We'll assign our fuselage, and then we'll assign all of our components with trailing edges to our airfoil separation, as well as our vorticity CDI. Now we're going to go ahead and define a relaxed cut-a condition trailing edge along the fuselage in order to properly account for the body carryover loads generated there. Under trailing edges in the dialog tree, we're going to select fuselage, wake type, and then relaxed cut-a, as well as disable all wake nodes for numerical stability. Next, we're going to define our runtime conditions. We're going to select a 10-degree angle of attack, and then we are going to take a look at our wing to get the proper planform area to use as our reference area. We're going to double this value since we're mirroring the half body. We're also going to use the ruler tool to get a rough estimate of our reference length. Now we're going to initialize our simulation by selecting subsonic for our model, mirror symmetry since we're using a half model, and a termination X location of the default value. We're going to choose our preferred color map settings. And now we're going to run our simulation. As we defined our axial vortex separation boundary conditions, we can see that the angle of attack of 10 degrees is producing two wake filaments that are shedding as vortices off of the fuselage. We can see the convergence of our simulation in real time either by checking the log window or the plots scene. And with that, our simulation is converged and we have our solution. Thank you for tuning in to this Flightstream tutorial.